Alright, physicists, so we're going to talk about acceleration. Now, acceleration basically is any change in speed, so if we're talking scalar measurements, any change in speed, that's faster or slower, or if we're talking about vectors, any change in velocity, and this means faster, slower, or change in direction. So when you go around a corner, you're accelerating. When you're going faster, you're accelerating. When you're going slower, you're accelerating. We'll get to that bit in a second. Okay, so essentially, acceleration is a change in velocity and the time it takes, divided by the time it takes for that change to happen. So we write this like this. Remember it's got the little half arrows above for being a vector quantity. So A equals V minus U over T. So V is the final velocity, okay, so that's what you end up at. U is the initial velocity, and T is the time. So that's really simple if you think about it. So it's basically where you ended up minus what you started at, so that's your change in velocity, divided by the time it took to get there. Alright, so let's have a look at this. So if A equals final velocity minus initial velocity, initial meaning starting, over T, the units are going to be this. So it's meters per second per second. Alright, that means it's meters per second squared. So it's measuring the velocity that you change, so velocity meters per second, every second. So if you're accelerating at 10 meters per second, after 1 second, you've gone up 10 meters per second. After 2 seconds, you've gone up 20 meters per second. So it's the change in velocity every second. So going faster is called acceleration. Slower is called either deceleration or negative acceleration. And you'll see why in a second. Let's go back to this last one. Alright, so let's do some calculations. Show you how we use it. So Tom starts sprinting from rest, which means standing still, from rest, and after 10 seconds, he's running at 15 meters per second. Okay, so let's work out his acceleration and how he got there. So A equals V minus U over T. In this case, V equals, so final velocity is 15 meters per second. Initial is 0 because he starts at rest, and the time it took was 10 seconds. So it's 15 minus 0, that's 15, divided by 10, 1.5 meters per second squared. So of those 10 seconds, if he went at a uniform acceleration, so same throughout, every second he got 1.5 meters per second faster. So we've got Gabby now, she's driving at 40 meters per second and stops in 2 seconds. Slams on the brakes, she's in a school zone, doesn't want to run over a kid. Let's work out how hard she slowed down, how hard she stopped. So acceleration equals V minus U over T. Okay, so V is 0, because her final velocity was 0, that's where she stopped. U is 40 meters per second, because that's what she started at. And it took her 2 seconds to stop. So 0 minus 40 over 2 becomes minus 40 over 2, minus 20 meters per second per second. That's negative acceleration. And that's how we work it out. Now we can do a lot deeper calculations from this, but that's where we're going to start. Alright, good luck.